Okay, so I just want to address one thing before I go forward. Uh, basically, the test that's open out today, or it's due today. Uh, some people saying they had issues, and I addressed this yesterday. People have issues with the format. It's like that every single year. The only thing you have to do is download it as, I think you guys are used to like Google Docs. Just download it as a Word doc. That's it. And then when you open it up as a Word doc. Don't open it up as a Google Doc, okay? Because if you open up as a Google Doc, it messes the format, okay? Because I think some people had issues with that. So hopefully that helps. And I do have some people submitting tests, so I know it worked for some people. Because I see some people submitting the test. Okay, so let's see here. I got to be careful. Let me see. I won't share that part yet. Give me a second. Making sure. Yeah, I see people have submitted it, and therefore, and when I look at the submissions, I'm just going to look at it and see. Yeah, formatting is fine. You got to download it as a Word doc. That's plain and simple. And then it comes out fine. Okay. So hopefully you guys do that and don't open it up in Google Docs, and that fixes the problem. Okay. I think you guys are all used to Google Docs. That's why. Okay. So Reem, hopefully that answers your question. I see you put that in the chat. Okay. So let's get at it. Let's start today. Share my screen again and start with the land acknowledgement. We acknowledge we are hosting the lands in Mississauga of the Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognize the enduring presence of all First Nation, Métis, and Inuit people. Okay, so today's August 4th, day 5. Okay, again, that means there's going to be quiz number 5 because there's each day there's a quiz. So I didn't update your marks. So some people, you know, are thinking that there's nothing due. Unfortunately, there is stuff due. I don't know why. So if you join the class late and then you think there's nothing due, I don't understand how you cannot see that there's yesterday was a quiz due today, right? So all the people who seem to have joined the class late for whatever reason, there was things that were due, right? Every single day there's a quiz, 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 quiz. So just want to make sure that people thinking, oh, I joined a class late, I didn't miss anything. Well, actually you did. There's quizzes that you missed, okay? So hopefully those people can figure that out. Don't ask me questions now because now we're going to focus on the lesson. So the lesson for today, we start unit 2, quadratics. Unit 1 function test is due today, 11:59. So extreme values we're going to talk about, transformation, translations, completing the square, transformation, stretch and compression, and then a quiz on this stuff above due today at 11:59. I don't think I've activated the quiz, so give me time. I'll activate the quiz after the meeting. Before you guys log out, I want to make sure you guys can access the quiz, okay? So don't jump off at the end. Just give me some time and we'll make sure we can all access the quiz. And let's get to the first lesson for unit 2. All right, looks like you guys can see everything. Okay, so the first lesson is extreme values, where we talk about max and min. And let's look at the video. So there's two videos. Let's go to the first one.
Here's just a quick lesson on completing the square. So this is just designed to be a refresher lesson reminding you of the method of completing the square. So completing the square is a method that helps you turn a quadratic that's and changing it into vertex form. Now, I've done
okay, where you had a quadratic, because we're talking about quadratics, and you go from quadratic, or you go from standard form, okay? You go from standard form to vertex form. And the way to do that, this is review, the way to go from standard form to vertex form is by doing this process of completing the square. Okay, so that's what we're going to be doing today. I mean, I guess doing a little refresher for that. Okay, so that's what we're watching right now.
more detailed explanation of why I'm doing the steps that I'm doing. Look at one of the previous lessons I've posted on completing the square. This is just designed as a quick refresher on the steps to complete the square. The reason why we want to change a quadratic from standard form to vertex form is that we can quickly pull out the vertex of the quadratic.
So when you pull out the vertex, right? So the vertex of the quadratic. So let me just draw on the screen here, because you guys need to remember. Okay, so I'll use a different color. I'll use blue. People are still coming in. Okay. So if I draw my graph like this, and here is, I'll draw, here is a parabola, okay? And then my point right there is my vertex, right? That vertex is made up of my H and K value, which is in my equation. That's the reason why you have to go from here to here. Because if you look at the standard form, you cannot come up with the vertex looking at this, right? So the only way to come up with the vertex is actually converting it from standard form to vertex form. And when you convert to vertex form, you can find your vertex. And your vertex, and depending on what values is your A, if it's a minus, then it's going to be opening it down. If it's a positive, then it's going to be opening up. Okay, that's the reason why we do this. Okay, so now here are the steps to go from standard to vertex form. I can explain it right now.
The vertex of a quadratic that's given to you in vertex form is HK. So if we have it in vertex form, we can pull out the vertex HK, state whether it's a max or a min. If A is positive, it's a min. If A is negative, it's a max, because if it's negative, it opens down. If it's positive, it opens up.
Why did I get promoted? Because I'm awesome and because I'm using WordTune. Last week.
In the previous, I won't explain too much, but basically, to get from standard form to vertex form, the key thing we're going to need to do is create this right here. This is a binomial squared. To create that thing in brackets squared, that binomial squared, we will have to have this right here or this right here. These are both examples of perfect square trinomials, and there's a step-by-step method to create this perfect square trinomial so that when we factor it, when we go from here to here, when we factor it, we get this binomial squared, which is the key component of vertex form. So I'll go through those steps with you through a few examples. I think we'll just do 3 examples, just quickly. So if you want, pause the video, read the steps. I'm not going to read through them now.
Okay, so here are the steps to do completing the square. Okay, we actually have to go through it. But step 1, put the brackets around the first 2 terms. okay? Factor out the number in front of the x if there's a number in front of x, or x squared. Look at the last term in the bracket that you bracket out the first two terms, divide it by 2, then square it. Then add and subtract the term behind the last term in the bracket. Okay, I know I'm reading this, you guys won't get it because we have to actually do, but I'm just going to continue. Move the negative term outside of the bracket by multiplying it by the a value. Okay, so now let's go look at an example. Here's an example right here. So we want to change this into vertex. So the first step, okay, so we're going to write it out. First step is to put brackets around the first two terms, right? So we're going to have here x squared plus 8, okay, come on, pen, plus 8x bracket plus 5. And then what we do is with that 8x, we divide it by 2 and then we square it. Okay. Someone just decided to join the meeting now. So I gotta add them in. Okay, so if I take the first term and divide it by 2 and then square it and then I add it. Okay, so let's do that. So y is equal to bracket x squared 8x, divide that by 2 and square it. So divide 8 by 2 is 4 squared is 16. And then I'm going to minus the 16. That's like adding an imaginary 0, okay? That's what you're doing right there. And then I have my plus 5, okay? So this is like adding 0 inside here, right? Plus 16 minus 16, it's 0, right? Isn't it? So now what I'm going to do is going to take out this negative number out of the bracket. So next step is going to be bracket x squared plus 8x plus 16. And the negative 16 comes outside the bracket like that. Okay. Now I'm going to factor. I do the complete. Basically, this is like a perfect square. So this inside here becomes like a perfect square. So two numbers that add up to 8, right? And then two numbers when you multiply together give you 16. Well, that is not 4. That means it's going to be 4 in one bracket and 4 in the other bracket. So it's just going to be a perfect square, which would be x plus 4 squared. And then minus 16 plus 5 means minus 11. So now this is my vertex form. Okay, so my vertex for this, okay, is made up of my h and k. I told you that from before. My pen is acting up. H. Okay, give me a second. My pen is acting up. H and K. And in this case, this is my H. This is my K. So it is 4 comma minus 11. That's my vertex. Okay. So if I'm plotting this, my vertex is 4 minus 11. I'm just going to say somewhere here. I don't know, somewhere here. And since the number inside here is positive in front of the bracket, it's going to open up. It's going to be something like this. Okay, so that's just the rough way I did it. Right, so now we're going to go through the explanation from the video, but that's the answer. Okay, this is in vertex form right here. Okay, so let's here.
Form, we need it to have this binomial squared involved. So we need to create a perfect square trinomial. These are the steps we're going to do to create the perfect square trinomial, so that when we factor it, we get this binomial squared so that we can easily pull out our vertex hk. Step 1, you put the first two terms in brackets, and you leave your c value, our plus 5, off at the end outside the brackets. Next is we need to then, so you notice it already starts to look like vertex form a little bit more, but we need to create a perfect square trinomial inside these brackets so that when we factor it, we get the binomial squared. Here's the trick for creating the perfect square trinomial. We're going to add 0 in a fancy way. What we're going to do is inside the brackets, we are going to add and subtract half of that 8 squared. So you take half of 8, square it, half of 8 is 4, 4 squared is 16. So what we're going to do is add and subtract 16 inside the brackets. I'll continue in red. So we keep our x squared plus 8x, and I'm going to add 16 and subtract 16 inside the brackets after it, and keep that plus 5 off at the end. So I've added 16 minus 16, that's 0. So I've added 0 in a fancy way. What I have inside the brackets here is a perfect square trinomial, and then this annoying minus 16. I need to take that minus 16 outside the brackets by multiplying it by the value in front of the brackets, which in this case is just a 1. So 1 times negative 16 is negative 16. So outside the brackets, it's going to look exactly the same as it did in the brackets. So I take that negative 16 outside the brackets, and my last step is going to be factoring this perfect square trinomial that I've created. And it's going to factor very nicely to a binomial squared if I've done things properly. I need to find two numbers. So when factoring a quadratic with an a value of 1, you find two numbers that have a product of your c value, a product of 16, and a
Okay.
sum.
Okay, so we know what the answer is, right? Because you see, we're getting to the same answer which I got, right? So we know it's going to be like that, and then my vertex form is going to be that. Okay, so now when you get the vertex form, you can answer these type of questions. The axis of symmetry of the parabola is the vertex a maximum? So what is the axis? What is the vertex and axis of symmetry? Okay, so let him explain that, but we have all the information from our vertex form of this quadratic now.
As well, I'll write that first. Axis of symmetry, that's the vertical line that passes through the vertex. It's always x equals whatever the h value is. In this case, h is negative 4. Our vertex
Study music theory, harmony, and ear training online with Berklee's renowned faculty. Download your free
is always hk. And in this case, our h is negative 4. Our k is negative 11, so the vertex is at negative 4, negative 11. Is the vertex a max or a min point? Since our a value is positive 1, that means the parabola opens up, which means the vertex is at the bottom of the parabola, so it is a minimum point. So I'll write min beside my vertex.
Okay, so we've done that. We're going to do this one here. The only reason we're going to do this one is because it's a little bit different, because you have a 2 now. You have a number in front of the x squared. So that kind of changes things. Okay, so we're going to do this one, but after it changes things, it's still the same, right? So so let me do this one quickly, and then we'll watch the video. Okay, so what happens is when I have that 2 in front of, well, first thing we do, which we always have to do, is put a bracket after the first two terms of the equation, right? So I put a bracket around this, if my pen works. Okay, minus 12x bracket plus 11. Okay, so we put a bracket around there. Then we need to factor out the 2 out of the 2 terms here, because there's a 2 in front of x squared, so we can factor it out, right? So I can put here 2 in front of the bracket. So this is divided by 2, this becomes x squared, and then this divided by 2 becomes minus 6x. And then I have here plus 11 outside the bracket. So now I do my thing where I divide this term here by 2, because we're adding a fancy 0. That's what we said, right? So we divide this term by 2, and then we square it. So 6 divided by 2 is 3, and then 3 squared is 9. So we're going to add 9, and then we're going to subtract 9 to make it a fancy 0 inside the bracket. So we have 2 outside, x squared minus 6x plus 9 minus 9. That's like still like adding 0. And because the equation doesn't change. We didn't change the value of the equation because we just added a fancy 0. But now, again, we want to take out this last term outside the bracket. But since it's inside the bracket, if I take it out, I can't just take it out as minus 9, right? I got to take it out and then multiply by 2. I got to multiply by the number that's in front of the bracket. So in order for this minus 9 to come out, it comes out, but I have to multiply by 2. So when I do that, that becomes minus 18. So y is equal to, I have here 2 x squared minus 6x plus 9. And then this becomes minus 18 plus 11. Okay, so now I can factor what's in the bracket here, right? I can use my product and sum, 2 terms, 2 numbers that add up to -6, and 2 numbers when you multiply them together give you plus 9. So those 2 numbers are going to be -3 and -3. So -3 together gives you -3 minus 3, add them, gives you -6. -3 times -3 gives you 9. So my factored form for this now is going to be x, I should say minus, not, erase that. It's going to be -3 squared. And then minus 18 plus 11 becomes what? -7, okay? So that's my vertex form, okay? The 2 in front of it, it's a +2. So I know it's going to be something like, so if it's my vertex form, it's going to be 3 and -7. So I'm somewhere here. 3 and -7, somewhere here. And the number in front of the bracket is a positive number. So now it's going to go something like this. Okay. And my vertex is 3 and -7. Someone's going to ask me why is it not -3? Because the formula for writing things in vertex form, if I were to show you up here, this is the formula to write things in vertex form. You have a bracket x, okay, minus h squared plus k. So the formula says minus h. So, but we know if it's minus h, that means the 3 there is -3. That means my h is positive. Okay, that's why. In the previous example, when we did it, we had a +4 or something like that. Therefore, my vertex was a negative, because if I have a plus in here in my equation, that means my h had to be negative, because a negative and a negative and negative gives you a plus. Okay, so that is my vertex, and then my axis of symmetry is the line that goes down the vertex. So my axis of symmetry, my x value is equal to 3. Okay, because that's and then we know it's a min because it opens up, and so that is basically the answer there. Okay, and we're going to go through the video and watch and explain again how to do this. Okay, so hold on.
We'll do 2 more examples. This one, there's going to be an a value other than 1 in front of the x squared, so there's a couple extra things we have to do for this one. Step 1 stays the same. You put the first 2 terms in brackets, and you leave your c value off at the end. Here's where another step comes in. Before we create our perfect square trinomial, we need to factor out the number that's in front of the x squared. We don't take out an x, we just take the number that's in front of the x squared. So I take out a 2. Divide both the terms in the brackets. I'm only factoring out from the terms in the brackets. So divide both the terms in the brackets by the 2 I took out, and I get x squared minus 6x plus 11. Now I create my perfect square trinomial in the brackets by adding and subtracting half of that 6 squared. That gives me 9. So I need to add and subtract 9 inside the brackets, and then I'll have my perfect square trinomial inside the brackets, which will factor nicely to a binomial squared. The only thing is I don't want that minus 9 in there. I had to put it there so that, because what I did was I added 0 in a fancy way to keep the value of the function the same, but I want that negative 9 out of the bracket, so I need to multiply it by what is in front of the brackets. So I need to distribute this 2 to that negative 9 to get it out. 2 times negative 9 is negative 18, so outside of the brackets, that negative 9 will change to a negative 18. So I have 2 times x squared minus 6x plus 9, negative 18 plus 11. Last step, factor my perfect square trinomial that is in the brackets. So I would find two numbers who have a product of 9, sum of negative 6. The two numbers that do that are negative 3, and factors are x minus 3 and x. Let's write our vertex axis of symmetry and whether it's a max or a min. So first of all, my axis of symmetry is x equals 3. My vertex is going to be 3, negative 7. And since my a value is positive, it opens up. So the vertex is at the bottom of the parabola.
Okay, so you see that's how you do that, okay? So let's see the next example. We may skip it if it's similar to this, so I just want to see what it is.
So it is a min point. Let's move on to this one since it has a fraction. Last example.
Okay, it has a fraction, okay. Let's see here. It's really not much different. Okay, let's just see that in fast pace. Okay, so again, you put in the bracket around the first two terms. Okay, so now the question you have to do now is you have to factor out 2/3, because what happens is the negative 2/3, you can't have a number in front of the x. So let's see, next step, right? He takes out the negative 2/3 out of the bracket. So your first term is going to be x squared. And then this is going to be, let's see what happens. You have to divide 8 by negative 2/3. So let's see, what does that look like? Right, see, there you go. It's going to divide 8 by negative 2/3. So when you divide by a fraction, that means you multiply the reciprocal, right? See, that's what it's going to do there, multiply the reciprocal, which is now you're multiplying 3 over negative 2. So 8 times 3 is what? 24. 24 divided by negative 2 is negative 12. Okay, so the answer is going to be negative 12. Okay, so put it through. Okay, so now I complete the square of divide negative 12 by 2 and then square it. We know divide negative 12 by 2 is 6, negative 6, and square negative 6. Negative 6 times negative 6 gives you positive 36, right? There you go. And then we had minus 36 as well. You take it out of the bracket, then you have to multiply negative 2/3 to the negative 36. Okay. And you get 24 and so on. So it's the same process, right? Now, what two numbers that add up to negative 12 and then give you 36? When you multiply, it's going to be negative 6. So in my bracket here, I'm going to have x minus 6 squared, right? So here we go. There you go, x minus 6 squared. So, and then plus 29. So we're done, right? So it's the same process. It doesn't matter if it's a fraction. Here is my vertex. My vertex is 6 and 29. That means my axis of symmetry is 6. Just fast forwarding. There you goes my vertex, 6 and 29. And then is it a min or a max? Well, I see a negative number in it here, so that means it opens down, so therefore it is a max. Okay, it is a max. Okay, so that is how we go from that. So we got to go a little bit quicker now because we have more lessons to go through. So let me stop this video, and we're going to go on to the next one. So give me a second. There's things in my way here, so let's get to that. So we'll watch this one. Let's see if this one is of significance to watch.
Okay, here's another part to the 1.3 finding the max or min of a quadratic lesson.
Okay, we'll skip that. We don't really need to go through that. Here is I didn't post the worksheet yet. I'm gonna post the worksheet after we are done now. But let's go to the next video, which is basically the translation. Yeah, we gotta do translation. So the translation is determining how the parabola, is it stretched? Is it compressed? Does it move left and right? Does it move up and down from the parent quadratic? Okay, so that's what we're gonna watch right now. That's basically introduction to transformations.
I need to find the best way to learn math and science.
It's Brilliant.org.
Whoa.
Brilliant has thousands of interactive lessons in math, science, and computer science.
I'm just introducing to you transformations of functions. We're going to look at a few different functions and transformations of those functions this unit. First function, we're going to look at the function f of x equals x squared, so a basic quadratic function. We'll apply different parameters to that function. We'll call this the parent function of quadratics and see what transformations happen when we apply different parameters to that. We'll also look at the function root x, and we'll also look at the rational function 1 over x. So we'll work with those three, we'll call those parent functions, and we'll look at how we can transform the graphs of those functions by applying different parameters, we'll call them a, k, d, and c, to the equations of those parent functions. So first of all, when I'm saying transformation, what does that mean? So basically a transformation means we're either going to be shifting the function, so shifting the graph of the function either left, right, up, or down, or we're going to actually be changing the shape of the function by doing what's called vertical or horizontal stretches or compressions, or also vertical and horizontal reflections. And how we're going to do that is by looking at the parent function f of x, so like these were different parent functions we're going to work with, and we're going to apply different parameters to those parent functions. We're going to apply the parameters a, k, d, and c. And this is
okay. So these a, k, c, and d is what we determine the translation or transformation. So the a will stretch or compress on the vertical of the parabola. Let's look at a parabola for a sec. It will stretch and compress the parabola vertically. X will, or sorry, not X, K will stretch and compress the parabola horizontally, right? So if it stretches, it's almost like pulling this way on the X. If I'm compressing, the K will push it this way, okay? And if I'm stretching on the Y, I'm stretching like this. If I'm compressing on the Y, I'm doing this, right? And then D is it basically moves the parabola left or right, right? If it's just a regular D, like a regular number, like a positive number, that means X minus a number. That means it's shifting it to the right. If this becomes X plus a number, that means that number would have been negative. That means it's going to shift it to the left. Okay, and then C or D makes the parabola move up and down, right? I'm using as a parabola as an example, but you can see at the beginning we have different types of graphs. We may have a rational, which is the x in a square root, or 1 over x. Sorry, x in a square root is a radical, and then 1 over x, that's a rational, okay? So this applies to all three examples of graphs. So here we go.
This is the general form of the equation of a transformed function. So g at x would be the equation of a transformed version of the function f at x. We'll call f at x the parent function, and we'll call g at x the transformed function. So g at x is equal to some transformed version of the parent function f at x. But what we've done to f at x is we have applied the parameters a, k, d, and c to move the graph of the function f at x, to stretch it, to compress it, shift it left, right, up, and down, or reflect it. So let's just quickly look at, before we get into these functions, x squared root x 1 over x, let's just quickly look at, before I explain what a, k, d, and c do exactly, we're going to quickly look at just a basic function like this. And we'll do transformations to that before we actually look at quadratics, radical, and rational functions. So I mentioned a, k, d, and c. So here's the equation of our transformed function g at x. It's equal to a times f at x with k, d, and a c in here as well. And what we're going to do is we're going to look at what exactly do these a, k, d, and c parameters do to the parent function f at x. So we'll go one at a time. We'll look at the vertical transformations first. So the vertical transformations are going to be a and c. And then the horizontal transformations are going to be caused by the k and d parameters. So let's look at a and c first. So c, that's just going to shift the function up or down. If c is a positive number, so if it's greater than 0.
Okay, so we're gonna go through this pretty quickly. C shifts it up and down. We know that. And then a in front of it compresses it or stretches it, okay? And if a is a negative, that means it flips it over the x-axis, and it could become either a max or min depending on the graph, okay? And now we apply d. D shifts it left or right, like I said before. If the value of d is positive, therefore it shifts it to the right. If the value of d is negative, that means this equation becomes plus. That means it shifts it to the left, okay? I think he's showing you an example here where f of x plus 5, that means that 5 has to be negative, right? You can see that's how you got a plus 5, because it's supposed to be like that. So therefore it shifts it to the left, okay? Now we're looking at compression, okay? So what happens if the number there, if k is not a fraction, okay? That means, so what you apply k? You apply k as a factor of 1 over k. So a factor of 1 over k will let you know if it's of compression or a stretch. If it is, if I put k and I put 1 over k, if 1 over k turns out to be a fraction, therefore it compresses. A fraction means it's going to be less than 1, okay? So it's less than 1. So if k is greater than 1, my bad, if k is greater than 1, therefore this is going to be 1 over a k that's greater than 1. Therefore it's going to be a fraction. And therefore a fraction will compress horizontally, okay? Now, if this value of k is, let's say if it is, say, less than 1, say this is a decimal, say k is a decimal here, right? 1 divided by a decimal gives you a big number. Therefore, my factor would be a bigger number. Therefore, that means I'm stretching it. I'm stretching it this way, okay? So if K is a decimal number here, what it does is it actually makes the parabola bigger on the X axis. So it stretches it, okay? And then obviously if it's a negative value for the K, then it basically, it reflects above, around the X axis. Okay, so we have to see all these different examples as I'm explaining it. Okay, and then, so it says here, look, note, vertical stretch or compression means that the distance from the Y axis of each point of the parent function changes by a factor of 1 over K. Okay, so each value on the, it moves by a factor of 1 over K from the X axis. I mean, it's moving along the X, right? But you multiply by a factor of 1 over K for each value of your X. Okay. So the order of transformation, you do your stretches first, then your compressions, then you do your reflections, and then you do your translations. Okay. So here's an example of this one here. Well, this one here, it is, it moved on the X axis by +2. Therefore, since this is a +2, that means it's going to be actually a -2. That means I'm actually moving this way. So each value of my X goes this way by -2. So here I'm at -3, this point. It's going to go to -5. This point here, it's going to go over to here. This point here, it's going to go over to there, and so on. So now watch the graph. Right? That's my D, like I said, so I'm going to move. Everything shifts to the left, like I said. So there you go. There's all the shifts, and he's going to redraw it, and you can see it shifts. So everything moved this way, okay? Because that's what it says there, right? The negative, it's a -2 because here it's a +2. Okay, so you shift that way. Here's the next one. So this one here is there's a negative in front of f of x. So my translation is basically everything on my every point flips down about the y, excuse my bad, about the x-axis. Okay, so that means any value for my y becomes a negative now. So my y here is 2. Now it becomes -2. My y here is -3, becomes +3. Okay, so every value here gets multiplied by, every value of my y gets multiplied by a negative number, -1. Okay, there you go. Vertical reflection over the x-axis. So it flips it. There you go. So there you go. See, that's what basically we did there. Let's look at the next example. So that means every value for my y, I multiply by -1, okay? Because that's what we have there, a -1, an imaginary 1 there, but it's in this, we call it -1. Okay, this one here. So now this one here, this one is my f of x +3. So that +3 is telling me I'm going to shift my graph up by 3. That means my y value for the translation is going to increase by 3. So whatever my y value here is, the new y value is going to increase by 3. Okay, that means we're moving everything up by 3. Right, so that's the C value, moving everything up by 3. There you go. So we moved everything up by 3. Okay, every point went up by 3. Now this one here is a little complicated. You have a combo here. You have inside a bracket, you have a 2x, and outside you have a -1. So if I were to draw like the points, the regular points are basically 3 and 2. If I get all these points and put in the graph here on this table here, now my transformed table is going to be every value of my x, I'm going to multiply by 2, and every value of my y, I'm going to subtract 1. That's what's going to happen. This is my transformed table. Okay. So let's go through that. Okay, so g of x is a transformation of f of x. So every value of my x, I'm going to multiply by 2 because that's what I see up there. And every value of my y, I'm going to subtract 1. Okay. Oh, I'm sorry, I made a mistake. You're actually gonna multiply by, so since it was a 2 in front of the let me back up again so you can see that. So every value here, so it's 2x. So my factor that I'm going to apply to my x value is going to be 1 over k. So if my k is 2, so I'm going to multiply my x values by 1 over 2. So all of these here are going to be divided by 2 because I'm multiplying by 1 over 2. Multiplying by 1 over 2 is like dividing by 2. Okay, so all my x values I'm going to divide by 2. So that's good. Let's look at that. There you go. Right? X, all my x values are divided by 2 because I'm multiplied by a factor of 1 over 2. Okay, so all these are divided by 2. And then my y, I'm going to add, I'm going to subtract 1. So I'm going to shift down. So all my y values are going to be, I'm going to subtract by 1. Okay, so that's what we do here, right? So y values subtract by 1, x values divide by 2. Right, so these are my new x values for my plot. And these are my new y values. Okay, so you plot this and then it'll be the transformed of the original. Okay, so there you go. That's the transform. You can see it got compressed, right? And it shifted down by 1. Okay, I think that is it. So that is it for that. Okay, so that is the 2 lessons for today. Give me a second, guys. Do not leave. Do not leave, okay? I'm going to access the quiz for you, and I'm going to access the worksheets. So give me a second and don't leave. And then I'm going to ask you guys to see if you guys can access those things. Okay, hold on. Okay, guys, you should be able to access the worksheets. Again, the worksheets don't count for marks. Okay, so you can submit them anytime. There's no late. Even though I say when it's due, I'm just giving you, because the worksheet is for to understand your quiz, right? But there's no due date, right? If you don't submit it, you don't submit it. It's not for marks. Okay. So now give me a second, guys. I want to put the quiz there for you. I want to make sure you guys have access to that. So do not leave yet. So give me a second. Okay, guys, could you guys check? Actually, if you open the quiz, just see if you can see the quiz, right? Okay, and yes, I'll update all the marks for your quizzes. Okay, so your marks do not show like your second and your third because people are joining in late. So let me know if you can see the quiz for August 4th. You won't see marks for the unit test until next week, guys, because people are still working on it. Okay. Okay, you can see it. That's good. So if you guys can see the quiz, that is it. So you can see your worksheet. Worksheet doesn't count for marks. I keep saying. Today you have your test is due today, right? For unit 1, and today is also the quiz for unit 2. So there's many things you got to do. So I'll let you guys go. It's 10:07. You guys can work on the things for the rest of the day, and I'll update your marks for all the quizzes for unit 1. Okay, so all your marks will be updated for quizzes for unit 1. Okay, so take care, guys. You can log out. Bye.